When we get a large amount of data in front of us, we need to have a way to describe the data, especially when we don't know much about this data sets. One of the very useful language is statistics. Your data can be simple or complex, or your data can be large or small. But no matter how, we need to describe our data in some general ways. One of the way we can ask question is to say, hey, looking at this observation, is there any typical value in this data set? So for example, you have observation of the temperature in the summer in a particular city. You could ask question, what is the typical temperature in this season if you look at the samples across many years? And that typical value give you an idea of how this temperature behave, okay, or you have some kind of expectations. Okay? And the second question you can ask is how this value samples vary around this typical value. Okay? That kind of knowledge give you an idea of how much variation across different samples. And the third kind of question allow us to look at extremes or outliers. So these extremes or outliers usually are variations that are very high or very much off the expected value. And this kind of observation helps us to discover surprises. In statistics, the way we describe a typical value is to derive or come up with measures of a central tendency, such as means or medians. I'm going to talk about this concept a little more. So what is the mean and what is median in the data? Okay, the mean of a data is basically the average value across all the samples. For example, here I give you 10 values representing 10 samples. Okay? And if we talk about means, what you do is to add the value up and then divide it by the number of samples, which is 10. And we come up with a mean is 2.48. Okay? The median is a little different. Okay, the median is basically you look at the value, you sort them from small to large, and then you look at what are the values in the middle, just the kind of the middle parts. In this case, we have 10 values, okay? And if you talk about middle, you probably have both the fifth and sixth value are in the middle. Okay? So we're going to have 2.4, 2.5 both as kind of in the medium range. So if you just add it up and divide by 2, the median is 2.45, which is a little bit different from the mean. Sometimes this mean and median can be very different. Okay? The value of mean and median are sensitive to different kind of distribution of values. Okay? So for example, means is going to be strongly affected by any extreme values. One of the example talk about if there's a bunch of professors and in the room and you calculate their average salary, okay, you got one mean, and suddenly you got Bill Gates coming to the room, and then you calculate the average salary, and the average, the mean will go much, much, much higher. Okay, so just because of one person. However, if you calculate the median, it wouldn't change much, okay, because you basically sort all the numbers, and you're only looking at those things happen in the middle. Okay, so in this case, the mean and median can be very different. There's another set of statistical measures that trying to describe how wide the value spread. For example, we can simply look at the range of values for an observation set. In this case, an example is given that describes the 2,000 tornadoes in the U.S. Is kind of aggregated by states. And we can look at the number of tornadoes by number. So the tornado value could range from 0 to the low end, and there's one state, actually Texas, have 147 tornadoes. So this will be the range that shows the variations. Okay. A second way to describe the spread of value is to use the concept of standard deviation. This concept measures the deviation of the distribution of samples around the mean. So in order to calculate the standard deviation, the first thing we have to calculate the variance. Okay? If you know the variance, standard deviation is just a square root of this variance. Okay? To calculate the variance, first thing you need to do is to find out the mean. In this case, if you talk about this tornado distribution, the mean value for the number of tornadoes for a state is 21. Okay, now if we look at all the observations for each one, we find out the difference between the sample values and the mean, and then we square them, add them up, and that will be the variance. That shows how much variations in that sense. So standard deviation gives you a good idea of how the samples around are distributed or varied around this mean. So the larger the standard deviation is, the larger the spread of the value in the distribution. The third measure of the spread of a distribution is called interquantile range, or IQR. Or a quantile, first of all, need to be defined clearly. The interquantile range is defined around the concept median. So as you recall, the median is a value in the middle of this value range such that there's exactly 50% that's below it and there's a 50% above it. So in this case, we have the tornado data, the median value is 11. And then we can start to figure out the interquantile range by looking at the range of values between 25% quantile and the 75% quantile. In this example of a tornado distribution, we show that there's exactly 25% of the states that have less than 2 tornadoes. Okay? And then we have 75% of the states that have less than 28 tornadoes. So that's the range of values from 2 to 28 is the IQR range. This shows how much the spread of the value around this median. So this range also describes how values are distributed or spread, but is characterizing how values are spread around median rather than the mean. So we have talked about 3 measures of the value spreads. The question is, do I need 3 measures to characterize my data? Well, if I need only one, which one should I choose? So that requires some inside knowledge about how these 3 measures compare, what is the pros and cons of using one of them. Well, the 3 measures have different usage, in fact. For example, the measure of range gives you an idea of what's the minimum and maximum value distribution. On the other hand, a standard deviation gives you an idea of how these variations around the mean value. And standard deviation is a good characterization when the distribution is close to normal distribution. Okay, so there's a central tendency. However, if the data is tilted on one side or the other, and then the interquantile range have a better use because it can not only characterize how things are varied around the median, but also shows the possibility of extremes on one side over the other. We also need statistical measures that allow us to say which sample is outlier, which is not. In this case, we talk about outliers as those samples that have value that have extreme deviation from the central tendency. Central tendency could be the mean or could be the median. Okay, if you use the mean, the way we calculate the deviation is use the standard deviation. If you choose to measure the central tendency by the value of median, then we use the interquantile range as the characteristics of the dispersion. Okay. Either way, we're going to be able to measure how further a value away from this central tendency. For example, in the figure, we show the distribution of the number of tornadoes by state as a box plot. Box plots combine the measure of central tendency with the measure of the spread. So in this case, we have the median value as the center point, and then we use the interquantile range to describe the range of variations. Okay, so now given these two measures, we can actually look at the extreme values and see how much of the extreme value are away from the central tendency value. So we're going to use 1.5 times more of this interquantile range to decide the cutting points. Anything that beyond that range will be considered as extreme values or outliers. So in this box plot, you see there's two lines drawn on the lower side and another line drawn on the upper side. So the upper side basically is the value that characterizes 1.5 times of IQR beyond the 75% range. That use the box plots, we call it box plot, to describe. So there's interquantile range in the middle, and so how far more than that is considered as extreme, that depends. Okay, there are some general rules. If the value is 1.5 or 3 times more than the interquantile range above the 75% quantile, then we consider them as the outlier.